Hey guys, welcome back for our very last video of Chapter 7. Let's take a look at similarity, perimeter, and area ratios. So take a look at these two triangles that we've got here. We've got triangle ABC and triangle DEF, and they are in fact similar to each other, but let's just check that out real quick. Let's take the longest sides, AB and DE, and then we'll take the medium sides, AC and DF, and the short sides, BC and EF. All of those ratios, I'm sure you guys can even look and just tell, they all simplify down to 1/2. So hopefully you guys agree that they are similar to each other by side-side-side similarity. All the ratios are equal to each other. Well, let's see if their perimeters have any special type of relationship. So remember that perimeter means take all the sides and add them up. So if we want to know the perimeter for triangle ABC, and then we want the perimeter for triangle DEF. Just add up the sides, right? So if we add 5, 4, and 3, we get a total of 12. And then if we add 10, 8, and 6, we get a total of 24. And we can simplify that down, right? 12 over 24 becomes 1/2. Hopefully, you guys are seeing something here, right? The similarity ratio and the perimeter ratio then are the same. The ratio of the sides of similar triangles and the ratio of the perimeters of those similar triangles have to be the same. So they both are 1/2. Kind of cool, right? Let's check out their areas. Let's see if they have the same ratio then. So finding the area of triangle ABC and the area of triangle DEF. Hopefully you guys can remember area of a triangle is 1/2 base times height, and the base and height have to be perpendicular to each other. So quickly we can go over and check our triangles. If we look at the little one, this 3 and 4 are my base and height because those ones are perpendicular to each other. And the 6 and the 8 are perpendicular in my big triangle. So we can find those areas really quick. The area of the small triangle is 6, and then the area of our big triangle is 24. So that simplifies down to 1/4. Well, that's not the same as the other two ratios that we got, right? It is, however, the same if we made it 1/2 squared. So the relationship between the similarity ratio and the area ratio is that you have to square it, which kind of makes sense because anytime we talked about area, we had the units being squared, right? So it's easy enough to remember. But let's jot these down just as, not formulas, but quick things for us to check and remind ourselves later. So if the similarity ratio of two figures is A to B, I'm going to say A over B, then the ratio of their perimeters is also A over B. So that's nice and easy because they're the same. And the ratio of their areas is A over B squared. So you take their similarity ratio or the ratio of their perimeters and square it, and you get the ratio of their areas. Simple enough, right? Now it's just a matter of using some proportions and solving them like we were before. So take a look at example 1 down here. We're given that the triangles are similar to each other, so we have the similarity statement already, which is kind of nice. We want to find the perimeter and the area of triangle UVW. So we're trying to find area and perimeter for this triangle based on the fact that we know these ones are similar to each other. So the first thing I'm going to do is find the similarity ratio between the two triangles. So if we look at triangle RST and triangle UVW, we need to find the ratio between their sides. So they gave us RS and UV, and if we check out our similarity statement, RS and UV have to be proportional to each other, so we can figure out what their ratio is. 16 to 20, which we can simplify down to 4 over 5. Well, if I have the ratio, the similarity ratio, then that means I have their perimeter ratio as well. So let's go over here and do the perimeters. So I know that the perimeter of triangle RST is 36, and I'm looking for the perimeter of this one, but their similarity ratio is 4 over 5. So I'm going to start there, 4 over 5, and my triangle RST is the one that's on top, and triangle UVW is on the bottom. So I'm going to put that over there just so we remember the order is important, right? So 4 over 5, and I know the perimeter of RST is 36, so that can go over P, the new perimeter that I'm trying to find, and all we have to do then is cross multiply to solve for P. So we end up getting 4P is equal to 180, and P is then going to equal 45. But remember, we've got some units going on here, so we need to know what our units are. For perimeter, it's linear, so it's just feet. And there we go. That's it. Then we have to look at their areas. Well, if I know that their similarity ratio is 4 to 5, that means that the ratio for their areas has to be 4 over 5 squared. So I have to square both of those, and I get 16 over 25. So now instead of using the 4 over 5, I have to use that 16 over 25. So let's set up our area ratio over here. So 16 over 25 is going to equal the area of triangle RST, so 48, over the new area of triangle WUV, which I'm trying to find. And again, we can cross multiply and solve for A. You guys should be pros at cross multiplying by now, right? We've done it a lot so far this chapter. But we get 16A is equal to 1200. Divide by that 16 and we get A is 75. And I'm going to put it in here just so I can put my units too. So 75 feet squared, because now we're talking about area, so our units have to be squared. All right, it should not be that bad, you guys. If you look at number 2, it's actually very, very similar to number 1. So I am not going to do it for you. I'm going to have you guys do that on your own for homework. So when you come into class tomorrow, I want you guys to have that question done. We will check the answers with each other tomorrow before we start on the practice. Cool? That way we can make this a shorter video for you guys. So let's take a look at example 3 then. This time, the only difference is that we are not given a picture for this one, so we're going to have to kind of improvise here. So I'm going to draw one real fast. ABC is going to be similar to DEF, and it doesn't matter how long the sides are or anything like that, because I just need to get a picture in my head of what's going on. So these two triangles are similar to each other. BC is 4 millimeters. And EF is 12 millimeters. They're telling me that the perimeter is 42 millimeters, area is 96 millimeters for triangle DEF. So they're giving me this one. Perimeter is 42 and area is 96. So I need to find the perimeter and area of this triangle over here. So let's do the same thing we did on the other one. Start with the similarity ratio. And I know you guys probably think that this is a waste of time to write it out this way, but I promise you it will help you in the long run. All right? So similarity ratio, let's do triangle ABC to triangle DEF. So ABC, we've got 4 for BC, right? And if we look over here, BC and EF are proportional, so we're good to just do 4 over 12, and we get 1/3. That means that that's also the ratio of their perimeters. So let's try and find the perimeter. Triangle ABC is the one that I don't know. So if I start with my 1/3, ABC is the one that I don't know, so that P has to go on top. But triangle DEF I know is 42. Cross multiply, and we get 3P equals 42 So solve for P and we get 14 millimeters. And then let's do the areas over here. But we need the ratio of their areas, right? So the ratios were originally 1 to 3. So we have to square that. Remember to square at both the top and the bottom. In this case, it's a 1 right on top, so it doesn't really matter that much. But anytime it's not a 1, like it was in example 1, you have to be careful. But in this case, we get 1 over 9. So let's go ahead and set up our proportion. We get 1 over 9 equals the area of triangle ABC we don't know, so that's going to be an A. And the area of triangle DEF we know is going to be 96 millimeters. And then we are just going to have to cross multiply. Hey guys, I have no clue what just happened there, but the last couple seconds of my video got cut off for some reason. So the last thing you heard is that we're going to have to cross multiply. And when we cross multiply up here to solve for A, we get 9A equals 96. Solve it, we get A equals 10 points. Technically it's 10.6 repeating, but we can go ahead and just round to the nearest tenth. So 10.7 millimeters squared. And that's it for that question, okay? Then the last question is super simple. We're given these two similar triangles and we're given the ratio of their areas. So the thing we have to know is that if we're given the ratio of their areas, we're going to have to take the square root in order to get back to the similarity ratio and the ratio of their perimeters. So square root of 49 over 81, we just get 7 over 9. And we look out, that's just the answer for both of them. There's no other work there. So I'm really sorry about the video, but this one at least is only about a minute, and it's not that much time out of your day to click on it and watch it. So give number 2 a shot. I'm sure you guys can do it no problem. If you have questions about it, we'll talk about it in class, and then we'll do some more practice and get you guys ready for your quiz. All right? Bye.